Humans have been in space for over 50 years, but it's always been about surviving in space. Only in the last few years, it has been about thriving in space. If we want to have a permanent settlement on the moon, on Mars, and that's what we are working with. We try to make stimulating, healthy environments that might even be better than your home here on planet Earth, right? And that's a big challenge. My name is Sebastian. I'm the co-founder and lead architect of SAGA Space Architects. We design architecture in extreme environments, and we are in one of our habitats right now. Our biggest goal is to have healthy humans in space. People that feel good, that are healthy, that are strong. To enable the future of habitats in outer space, several novel manufacturing methods will be used. But the most interesting one is 3D printing. The opportunities with a 3D printer is that you can just send a 3D printer and nothing else, and then use local materials on the surface of the moon or on Mars to print the structures that you need. And then the astronauts move in and can live there.
Whereas regular architecture, you have some constraints in one way, and for space architecture, you just have a completely new set of rules. But the game is sort of the same. You have to develop a project within those rules. And that is actually the fun part.
We are very happy that we started switching to software like Fusion, because it's just a perfect tool for collaborating several people on like a complex geometry that has a lot of different requirements that need to be fulfilled. And sitting and designing where every single little bolt and wire and cable and device is going to be exactly, it can be quite complex to keep track of. We rely a lot on being able to do a full replica of the thing that we want to make into reality in the digital world first.
We can also do the CAM programming for the CNC machines or generate toolpaths for the 3D printers. We can also do renderings. Normally when you design a house, you need to develop it to a building code, but the consequences in space are just immediate. And that means that there's a lot of compliance reviews, there's a lot of reviews throughout, also just internal reviews just to make sure that the quality is what we want. This type of design software is easy even for non-technical people to work with, or with non-specialists. So people without 3D modeling can still review through a shareable link, a 3D model. They can do some section lines, they can understand the proportions, they can review whether or not the cable trays are large enough for that type of wire to go through. Then in some of the other software suites like Revit, for example, we can do all the documentation and drawings and working together with the municipality to make sure that we comply with all the regulations. So really here we have for the first time one family of software that allows us to go from 0 to 100 without changing.
For me personally, one of the best parts of doing these kind of things is to see the thing you've worked on for months and years exist in real life and walk inside. And it looks just like it did in the digital version.
Our latest habitat, the one we're in right now, will be used for the next 20 years to train the European astronauts, preparing them to go back to the moon. So it will actually be probably one of the most heavy used training habitats in the world. One thing that is very clear to me is SAGA can exist now as a small company doing pretty ambitious projects because of the technology we have. We wouldn't have been able to do this 10 years ago, 15 or 20 years ago. I know in the morning when I go into work that in this environment, we can do anything. The people here, the tools we have, the machines we have, the software we have. If I have a dream in the night, then I know my team can build it the next morning. And that power and freedom is everything I ever wanted.